Hello students, I am Dr.R. Professor, Department of Mechanical Engineering, RVS College of Engineering, Dindikal. I posted previously two videos on Unit 1 and Unit 2 for the subject Robotics. These videos are exclusively for multiple choice questions, and these videos will be much helpful for you to write the forthcoming unanimous examinations, because for the forthcoming unanimous examinations the question pattern is multiple choice questions instead of descriptive type. So please follow this video. This will help you to understand how the MCQ questions will be asked, multiple choice questions will be asked. So we'll go into the video. This is for Unit 3, Sensors and Machine Vision. So as I already mentioned, there are two sections, Part A and Part B. First we are going to see the Part A, Unit 3, Sensors and Machine Vision, Part A. So question 1, sensors are required in robots to get. The choices are A, information regarding velocity and position, B, information from environment, C, both A and B. So the answer is C. So there are two kinds of sensors are used in robots. One is to collect the information regarding velocity and position. They are called as internal sensors. And B, some sensors are used to collect information from the environment. They are called as external sensors. So both kind of sensors are used in robots. So the answer C is the choice C is the correct answer, both A and B. The second question, internal and external sensors are used in robots to A, collect information of the environment and operate the drive units respectively. B, operate the drive units and collect information of the environment respectively. C, collect information of the environment only. D, operate the drive units only. So in the first question itself I told, so the internal sensors are used to collect the information regarding velocity and position to drive to operate the drive units. Some sensors are used to collect the information from environment. They are called as external sensors. So the option B is the right answer. Internal sensors are used to operate the drive units and external sensors are used to collect information from the environment. So answer B is the choice B is the correct answer. The third question, LVDT is used to sense A, displacement, B, velocity, C, proximity. So LVDT, the full form is linear variable differential transformer, is used to sense A, the displacement. So it is used to sense the displacement. This is a displacement sensor. Fourth, the displacement and its direction are measured in LVDT by A, phase difference and amplitude difference of secondary coil voltages respectively. B, amplitude difference and phase difference of secondary coil voltages respectively. C, null position voltage. So the displacement is measured by the amplitude difference, and the direction of movement, whether it is a positive direction or negative direction, that is measured by the phase difference of secondary coil voltages. There is one primary coil and two secondary coils. So accordingly, the position of the core, the secondary coil, the voltages are going to develop. So the amplitude difference is used for measuring the phase difference. The amplitude difference is mainly used for measuring the displacement, and phase difference of secondary coil voltages are used for measuring its direction. So, fifth question, resolver is used to measure A. Linear displacement, B. Linear velocity, C. Angular displacement. So, LVDT is used for measuring linear displacement, we know. So, that is not the right answer. The A is not the right answer. It is not used for measuring linear velocity also. So, resolver is used to measure angular displacement. So, for linear displacement, we are using LVDT, and for angular displacement, we are using resolver. Question number 6. Which of the following statement is true for incremental encoder? A. It is non-contact type position sensor. B. It is a disc encoder with alternate transparent and opaque strips. C. The output pulse frequency is proportional to the rotational speed. D. All of the above. So remember, so incremental encoders are non-contact type position sensors. That is also correct. So, an incremental encoder is encoded with alternate transparent and opaque stripes. That is also correct. So, the output pulse frequency is proportional to the rotational speed. That is also a correct statement. So, all the three statements are correct regarding incremental encoder. So, the answer D is the option D is the right answer. All the above. Question 7. Which of the following applies to an index channel or Z channel? Okay. So, index channel or Z channel. So, A. Position tracker. B. Reference or homing point. C. Determining the distance. D. All of the above. So, there is a Z channel in the incremental encoder. So, what is its use or what is its application? So, it is used to track the position. It is used as a reference or homing point. It also used to determine the distance. So, all of the above is the right choice. So, D is the correct answer. So, next is the question is regarding the absolute encoder. In a 3-bit absolute encoder, decimal 3 is indicated A 110, B 101, C 011. So, in the absolute encoders, so this is actually a binary absolute encoder. So, in a binary absolute encoder, you have to convert each code into the decimal number. So, in the case of 011, binary is equivalent to decimal 3. First 1 multiplied by 2 power 0, second 1 multiplied by 2 power 1, 0 multiplied by 2 power 2. That's why we have to convert the binary into the decimal. So, obviously 011 is the binary equivalent of decimal 3. So, answer C, choice C is the right answer. Question 9. Let us consider an absolute optical encoder consisting of n concentric rings, that is tracks. So, its resolution is determined as A 1 by n square, B 1 by 2 power n, C 1 by n cube, and D 1 by 3 to the power of n. So, the answer is 1 by 2 power n. So, if there are n concentric rings or n tracks, it can its resolution is equal to 1 by 2 power n. Answer B is right. So, question number 10. Which one of the following statements is false? A. Incremental optical encoder is less accurate compared to absolute optical encoder. B. Incremental optical encoder is more accurate than absolute optical encoder. C. Incremental optical encoder is less expensive compared to absolute optical encoder. So here the question is, which one of the following statement is false? Okay. So incremental optical encoder is less accurate compared to absolute optical encoder. This is a true statement. And first option C, incremental optical encoder is less expensive compared to absolute optical encoder. That is also a true statement. So only the false statement is incremental optical encoder is more accurate than absolute optical encoder. So this is a false statement. So obviously incremental optical encoder is less accurate than absolute optical encoder. That should be there, but it is a false statement. So answer B, that is the false statement. So answer B is the right answer. Question number 11. A takeout generator is used to measure A. Speed, B. Displacement, C. Temperature. So takeout generator, so we know already it's like a tachometer, takeout generator. So remember like that. So takeout generator is used to measure speed, A. Speed. Takeout generator is a sensor used to measure speed, A. Speed. So the question number is wrongly typed actually. So it's again, we can keep it as 11th question. For a proximity sensor, which one of the following is wrong? A. It is a non-contact sensor. It is used to detect the object within a distance. It will measure the distance of the object. So obviously a proximity sensor is a non-contact sensor. That is correct. Second one, it is used to detect the object within the distance. That is also correct. So the third one, it will measure the distance of the object. That is the wrong answer. That is the wrong statement actually. So answer C is the right answer. So the C, it will measure the distance of the object. So proximity sensors only detect, they don't measure, right? So that is the difference between a proximity sensor and the range sensor. Proximity sensors, they only detect the object. They don't measure the distance between the sensor and the object. But contrarily, range sensors, they detect the object as well as they measure the distance between the sensor and the object. So that is the difference. Please remember this point. So 12. Ferromagnetic objects can be sensed by A. Induction sensor, B. Hall effect sensor, both A and B. So the following questions are related to the proximity sensors. Okay, all these sensors, ferromagnetic sensors, and some sensors we are going to see continuously. They are all coming under the category of proximity sensors. Remember, ferromagnetic objects can be sensed by A. Induction sensor, B. Hall effect sensors, C. Both A and B. So the ferromagnetic objects can be sensed by both A and B. Either in the induction sensor or in the Hall effect sensors, we can sense the ferromagnetic objects. So the ferromagnetic objects is going to cause a change in the induction or in the coil. So by that we can sense the ferromagnetic objects by induction sensor. In the case of Hall effect sensors, it is going to reduce the Lorentz effect or Lorentz force. By that actually the external voltage is going to reduce. By that we can measure the we can detect the ferromagnetic objects, that is Hall effect sensor. So both A and B can be used for detecting the ferromagnetic objects or sensing the ferromagnetic objects. Answer C is correct. So 13. Which one of the following statement is false? A. Capacitive sensor is suitable for non-magnetic material. B. Capacitive sensor is a range sensor. C. Capacitive sensor works based on the increase in capacitance due to accumulation of charge. D. Capacitive sensor is a proximity sensor. Answer is B. So capacitive sensors. So capacitive sensor, it's a proximity sensor. So answer D is a right statement. Capacitive sensor works based on the increase in capacitance due to accumulation of charge. That is also a right statement. Capacitive sensor is suitable for non-magnetic material. That is also a right statement. So only the wrong statement or a false statement in this is B. The capacitive sensor is a range sensor. So I already gave you the difference between the proximity sensor and range sensor. This is a proximity sensor. So capacitive sensor is a proximity sensor. Obviously it cannot be a range sensor. Question 14. Which one of the following statement is false? A. Hall effect sensor works based on Lorentz force. Hall effect sensor is suitable for non-magnetic material. Hall effect sensor is a proximity sensor. So we already know Hall effect sensor is a proximity sensor. Hall effect sensor works based on Lorentz force. So the wrong statement is, or false statement is, Hall effect sensor is suitable for non-magnetic material. So answer is B. Hall effect sensors can be used only for ferromagnetic or magnetic material. Non-magnetic material cannot be sensed by Hall effect sensor. So question 15. When the object is brought near the Hall effect sensor, the Lorentz force A increases, B decreases, C has no change. So the answer is B. When the object is brought near the Hall effect sensor, obviously the Lorentz force decreases. So question number 16. In ultrasonic sensor, the object is detected by A. Light reflection, B. Sound echo, C. Change in magnetic field. You know sonic means actually sound. So ultrasonic, you know the sound which cannot be heard by the human ears, which is called as ultrasonic, a high frequency sound. So the ultrasonic sensor, the object is detected by sound echo. Answer B is the right answer. So we have seen so far the different types of proximity sensor, like ultrasonic sensor, it's a Hall effect sensor, induction sensor, capacitance sensor. So all these sensors are proximity sensors. So now the questions are in range sensor, the second one. The principle used in range sensor: A. Triangulation, B. Structured lighting approach, C. Scattered lighting approach. Both A and B, right? So triangulation and structured lighting approach. So the answer is D. So triangulation principle is used in range sensor. Structured lighting approach is also used in range sensors. So answer D is the right answer. Question 18. Micro switch used in robots is A. Position sensor, B. Velocity sensor, C. Touch sensor, D. Acceleration sensor. So micro switch used in robots is a touch sensor. It is used as a touch sensor. So when we use the micro switch, when it touches the object, it is going to give a signal. So it is a touch sensor. Okay. So there are two types, analog and digital type of micro switches are there. Okay. Question number 19. Force or moment sensor used in robots consists of A. 4 pairs of strain gauges, B. 3 pairs of strain gauges, C. 8 pairs of strain gauges. So the force sensors or moment sensors use 8 pairs of strain gauges. So answer C is the right answer. So answer C is the right answer. There is 8 pairs of strain gauges. Question 20. For tactile array sensors, the one of the following is false. A. It is a matrix of force sensing elements. B. It is a non-contact sensor. C. Used for sensing the shape, size and orientation of the object. So, obviously the tactile array sensor is a matrix of 4 sensing elements. It is an array of 4 sensing elements. So, that is the right statement. C. Used for sensing the shape, size and orientation of the object. That is also a right statement or the true statement. So, second one, it is a non-contact sensor. It may be a pose sensor or a micro switch or tactile array sensors. All these sensors are going to be contact type of sensors. B, it is a non-contact sensor, is the wrong answer or false. So that is the false statement. So that is the right answer. Answer B is the right answer. This is a false statement. It is a non-contact sensor. It's a false statement. Okay. So 21, slip sensor is used to determine A, whether an object is slipping out of the gripper. B, the slip of a pump. C, whether the robot slips in the flow. So the slip sensor, it is used to determine whether the object is slipping out of the gripper. So answer A is the choice A is the right answer. So far we discussed about sensors. The next part is machine vision. So question 22. Machine vision is the process of A, seeing, locating and placing the machine. B, extracting, characterizing and interpreting images. C, providing vision to the visually challenged through machine. Okay. So the answer is B. The machine vision, it has 3 processes. One is it extracts, it characterizes and interprets images. So machine vision is a combination of these 3 processes. It extracts, characterizes and interprets images. So machine vision answer B or choice B is the right answer. 23. In backlighting technique is used for getting a disturbed light pattern, B, silhouette image, C, scattered light. So backlighting, when you provide backlighting, you will get a silhouette image. So answer is B. 24. The surface flaws can be easily identified by A, structure lighting, B, diffuse front lighting, C, directional lighting. So the surface flaws can be easily identified by directional lighting. Answer is C. 25th question. In Vidicon camera, the output video signal of the image is taken from A, electron gun, B, metal electrode film, C, photosensitive film. So all these 3 elements, electron gun, metal electrode film and photosensitive film, are the elements or the parts of Vidicon camera. So the output video signal of the image is taken from the B, metal electrode film. The answer is B. Photosensitive film or Vidicon camera has resistance A, directly proportional to the light intensity, B, inversely proportional to the light intensity, C, no relation between resistance and light intensity. So photosensitive film or Vidicon camera has resistance inversely proportional to the light intensity. So that means if the resistance is less for more light, that means it will produce it will produce more charge. By that it can produce actually more voltage signal. Actually the amplitude of the voltage signal is high in the case of bright light. Actually when the bright light falls on the photosensitive film, the resistance is going to reduce. By that more charges can be accumulated, and when it is scanned by the electron gun, the amplitude of the voltage produced is going to be high. So the correct answer is the resistance is inversely proportional to the light intensity. Answer B is correct. Question 27. When the output voltage of Vidicon camera is larger, when A, light intensity is more and the charges produced is less, B. Light intensity is less and the charges produced are more. C. Light intensity is more and the charges produced are more. Just now I told you, when the light intensity is more or a bright light falls on the photosensitive film, it produces more charges. So that is the right answer. So C is the right answer. When light intensity is more and the charges produced are more, obviously the output voltage is going to be larger. So simply remember, light intensity is more, the charges produced are more. So by that actually the output voltage of Vidicon camera is larger. So 28, in Vidicon camera, raster scanning is by moving electron gun over the faceplate for generating A. Audio signal of the scene, B. Video signal of the scene, C. Both audio and video signals. So the camera, the Vidicon camera, is mainly used for capturing the image. So obviously the choice B is the right choice. B. Video signal of the scene. So answer is B. 29. The standard scanning speed in Vidicon camera is A. 50 frames per second, B. 30 frames per second, C. 40 frames per second. So this is the scanning speed of Vidicon camera. So the raster scanning method we are going to scan. So that is one scanning is called as from the top right to the top left to the bottom right. That is what we are calling it as a one frame during the raster scanning. That is how many frames per second? That is the question. So it is 30 frames per second. Answer is B. 30. CCD camera means A. Closed circuit domestic camera, B. Computer controlled device camera, C. Charge coupled device camera. So the C, answer C is the correct answer. Charge coupled device camera. (31) In CCD camera, a serial register C is A. Imaging register, B. Storing register, C. Reading register. So the serial register C is reading register. So A and B, C. So this is the order. A is the imaging register, B is the storing register, and C is the reading register. So the CCD camera, there are three registers. A is given for imaging register, B is given for storing register, and C is given for reading register. So the serial register C is a reading register. Okay, 32. The sequence of operations in analog to digital conversion is A. Sampling, quantization and coding, B. Coding, quantization and sampling, C. Quantization, sampling and coding. So in ADC, analog to digital conversion, there are three operations, a sequence of operations. So that is sampling, quantization and coding. Option A is the right answer. Answer is A. In computer vision, frame grabbing is used for A. Convert analog information of light intensity into digital form, B. Store image in computer as an array of pixels, C. Remove noise and restore lost information from the image, D. Collect analog information of captured image. So the frame grabber is a storage device. So it stores image in computer as an array of pixel. So answer B is correct answer. Which technique is used for segmentation? Question number 34. Which technique is used for segmentation? A. Coding, B. Region growing, C. Template matching, D. All of the above. So region growing is the segmentation technique. So answer B is the right answer, or choice B is the right answer. The binary conversion thresholding technique The tool used is A. Flowchart, B. Bimodal histogram, C. Table. The binary conversion thresholding technique, the tool used is bimodal histogram. Answer B. Question 36. In machine vision, the technique used for grouping the pixels based on property is called A. Feature extraction, B. Object recognition, C. Region growing. So the technique used for grouping the pixels based on property is called region growing. Answer is C. 37. In computer vision, gradient operator is used for A. Thresholding, B. Preprocessing, C. Frame grabbing, D. Edge detection. So the gradient operator is used for edge detection. So answer is D. 38. Which of the following is false for object recognition in machine vision? A. In template matching, the feature values of unknown object is compared with that of the model template. B. In structural technique, both features and the relationships are considered. C. Without feature extraction, the object can be recognized. So in these three statements, we are having two technique, object recognition technique. One is called as template matching and another one is structural technique. In template matching, the feature values of an unknown object is compared with the model template, and in the structural technique, both features and the relationships are considered. So both the statements are true statements, and only the false statement is without feature extraction, the object can be recognized. That is false. After doing the feature extraction only, the object can be recognized. So without feature extractions, the object can be recognized as a false statement. Okay, so the answer is C. Question number 39. Mention the application of machine vision in robotics. A. Inspection, B. Identification, C. Navigation, D. All of them. So all the three, inspection, identification, navigation, all these fields, machine vision is used in robotics. So answer D. Choice D is the right answer. So now we will move on to part B questions. It is of more of analytical type. So question number 40. At time t, the excitation voltage to a resolver is 24 volts. The soft angle is 90 degree. The output signal from the resolver stator windings are A. 24 volt 0 volt, B. 24 volt, 12 volt, C. 12 volt, 0 volt. So we are going to give a excitation voltage. By that actually we are getting two secondary windings, VS1 and VS2 secondary voltages. So what are they? That is the question. So VS1 is V sin theta and VS2 is V cos theta. So V we know it is 24. So VS1 is equal to 24 volt into sin 90. So sin 90 we know is 1. So that is equal to 24 volt. VS2 is equal to 24 volt into cos 90. So where cos 90 is equal to 0. So that is equal to 0 volt. So from this we are going to find out the shaft angle. Right? That is the purpose of resolver. So what is the angular displacement? That is what we are going to find out from the resolver. So the answer is 24 volt, 0 volt. That is answer A. So 41 question. At time t, the excitation voltage to a resolver is 24 volts and VS1 is equal to 17 volts and VS2 is equal to minus 17 volts. What is the angle? That is the question. So we have to find it out from this. Actually, what is the sine theta value. So theta is equal to sine inverse Vs1 by V, that is sine inverse 17 by 24, that gives you 45 degree or 135 degree. So both are correct, 45 degree or 135 degree. Cos inverse minus 17 by 24, that is equal to 135 degree or 225 degree. So in both the cases 135 degree is common. So because the displacement cannot be two angles, it can be only one angle. So in both the cases the common angle is 135 degree. So the shaft angle is 135 degree, that is answer B. What is the resolution in degrees of an encoder with 10 tracks? So A is 0.7521 degrees, B 0.5414 degrees, C 0.3515 degrees. So the resolution is equal to 360 divided by 2 power n. So here it is 360 divided by 2 power n. N is number of tracks. So here 10 tracks. So 360 by 2 power 10, that is equal to 0.3515 degree. Okay, 3515 degree. That is actually answer C. So answer C is the correct answer. Okay. 43. In a triangulation range sensor, distance between the light source and the detector is 1 meter, and the angle of the light source with the baseline is 20 degree. The distance between the object and the detector is A 1.1 meter, B 0.36 meter, C 0.52 meter. So the hint is D is equal to B into tan theta. So what is B? So the B is distance between the light source and the detector, that is 1 meter, and the angle of the light source with the baseline, that is actually theta, that is equal to 20 degree. So 1 into tan 20, that will give you 0.36 meter. So answer is B. In an 44, question 44, in an ultrasonic time of flight range sensor, the time difference between transmitting and receiving the ultrasonic sound is 2 seconds. The speed of sound is 340 meter per second. What is the distance of object from sensor? A 340 meter, B 170 meter, C 85 meter. This is again a range sensor. We are going to measure the distance between the sensor and the object. So we are using ultrasonic sound. So we are using an approach called as time of flight approach. So starting from starting point to, again it will go and hit the object, and it will come back and it will be received by the receiver. So an emitter is going to emit an ultrasonic signal. It goes, hits an object, returns back, and it is received by the receiver. This is how actually an ultrasonic sensor works. So from this we are going to calculate the distance. The distance is equal to C into T. Obviously we know the velocity multiplied by the time, that will give you the distance, because it goes, hits the object and returns back, because it is it travels the distance in 2 times. Actually we are dividing it by 2. Why we are dividing it by 2 is we are sending the signal that travels one distance, and it comes back and it comes to the receiver, that again it travels another distance. So it travels actually 2 distances, the same distances. If you are taking distance as d, it travels 2d. So that's why we are dividing it by 2. So distance is equal to C into T by 2. So 340 is the speed of the sound into time 2 seconds divided by 2, it is equal to 340 meter. So A, answer is A. So 45, consider a vision system using a Vidicon tube. The faceplate has 512 lines, and an analog video signal is generated for each line. The scanning time per frame is 33.33 milliseconds. The scanning rate per line is A 65.1 microsecond per line, 131.3 microsecond per line, C 120 microsecond per line. So scanning rate per frame it is equal to 33.33 milliseconds. So if I convert it into that is actually scanning rate into 10 power minus 6, 10 power minus 3 actually, this 10 power seconds. So scanning rate for each line, scanning rate per frame divided by number of lines. So it is 33.33 into 10 power minus 3 divided by 512. So the millisecond we are having 33.33 milliseconds. So 33.33 into 10 power minus 3 divided by 512. So that will give you 65.1 into 10 to the power minus 6 second per line. So, okay. So that is the right answer. So 65.1 into 10 power minus 6 means it is 65.1 microsecond per line. So answer is A. What is 6? A continuous video signal is to be converted into digital signal. The range of signal after conversion is 0 to 5 volts. The A to D converter has an 8-bit capacity. The quantization level spacing is 0.0205 volt, B 0.0195 volt, C 0.01375 volt. So the quantization level is equal to the voltage, that is 5 voltage, divided by what is the bit capacity, that is 2 power 8. So 5 by 2 power 8, that is equal to 0.0195 volt. That is the quantization level. So P is the right answer. 47. The image of an object is represented by an array of pixels. The light intensity values at the different pixels are given. So it is given as an array. So you can see the array 180, 70 like that. The image is subjected to neighborhood averaging filter of 3 by 3. What is the intensity value of third row, second column? So this is the third row, this is the second column. So this, what is the intensity value after neighborhood averaging filter of 3 by 3? So what is the intensity value after doing the averaging filter? 3 by 3 neighborhood averaging filter. So you can see here, I am taking all the 3 elements. So it is a 3 by 3. So you can take 35, 65, 85, 54, 33, 87, 45, 46 and 45. The neighborhood 3 by 3 matrix. Okay. So this 33 is going to be in the center. So 35, 65, 85, 54, 33, 87, 45, 46, 45. That is for averaging filter. So I have taken that matrix, surrounding matrix. So now I am going to apply the average. So you know what is averaging. So you sum up all the numbers and then divide it by how many numbers are there. That is actually 9 numbers are there. So 35 plus 65 plus 85 plus 54 plus 33 plus 87 plus 45 plus 46 plus 45 divided by 9. So where this 9 comes from? How many number of elements are there? Okay. So that is equal to 55. So the answer is 55. Answer is D. So for the same problem, if you are applying a median filter, the pixel value is. So what is average filter, or it is called as the mean filter. So we are going to add all the values and divide it by number of elements. What is the median? So you know very well what is median. So if you want to find out the median, you have to write them in an ascending order. So I am writing all these numbers in an ascending order: 33, 35, 45, 46, 46, 50, 45, 46, 54, 65, 85 and 87. So now there are 4 elements in this side and there are 4 elements in this side. So this is the median value. So the 46 is the median value. So the answer is B. Dear students, I hope these videos are useful to you. If you find these videos are useful, please share it to your other friends also. That will help them to understand the MCQ questions and they can do better in their annual examinations. Thank you.